This time we're doing more testing. So, this is a tester, as you can see, mega. We've got a board here, a ring, which is very nice. So, when it comes to testing, the first thing we need to do is to make sure that the board is dead. Can you see the board? Yeah? If you need to zoom in to see in the board, zoom in. Okay? First thing we need to do is to make sure that the board's dead. Okay? You with me? Okay. So how do we prove that? You heard of safe isolation? Yes? Yeah. Okay. How many steps is there in safe isolation?
6.
10.
10 steps, yeah.
Yeah?
I know them, yeah.
Yeah, 10. Okay? So, what's the name of this?
Proving unit.
Correct, well done. A proving unit. So therefore, proper way, you can see proving unit. Okay? So therefore, this, what's the name of this?
Voltage indicator.
Voltage indicator. What does it have to comply with? What?
GS38.
Well done, well done. GS38. So therefore, we need to prove that the voltage indicator is working and the proving unit. Can you see that?
Yeah.
So therefore, and you can hear that, yes? So therefore you know that your voltage indicator is working and also your proving unit is working, okay? So if we should go over here to check, it's not going to be your equipment that's faulty because you've already proved that it's working. Do you understand?
Yeah.
Remember, this is not plumbing. There is no water to see.
Yeah.
By the time you see it, it's too late. Okay? Be safe. What does GS38 say about the tips?
They got to be 2 meters out, preferably 4.
So 4 meters, preferably 2.
Yeah. Sorry, other way around, yeah. No, millimeters.
Not protruding more than 4 mil, preferably 2 mil. Okay? Remember, from here to here is 1 meter. So it cannot be 4 meters. Okay? 4 mil. Okay? Right. So, we've got the proving unit. We've tested our voltage indicators working. We come back, we prove that it's dead.
Yeah.
The next thing you're meant to do is to prove it and a live source. That is definitely working, okay? Once we've done that, we know that's good, okay? This scenario, the first circuit that we'll be doing, the testing on, is a B6, so 6 amp. So what circuit would that be for a 6 amp?
Lighting.
Pardon me?
Light.
Lighting, well done, correct. So, can you see the sign?
Yeah.
Yeah? Okay. What you need to do is, you see this? When it's up, it's on, okay? This is the circuit that we're working on. So can you see this? It cannot be turned on, okay? You put this, with your lock, put it through there, and like that. Now, that is safely locked off. Yeah?
Yeah.
Okay? That's safely locked off. Can I leave this key?
No.
There?
It's got to be in your back pocket. It's got to be in your pocket. No.
Where should the key be at all times?
Your
In my
person.
pocket.
With you.
With me. Well done. Correct. Now, switch is off. The breaker is safely being locked off, isolated. Okay? Now we can identify the circuit. We've identified the circuit. We didn't need to get any permission because this is not someone's property. Okay?
Cool.
Right. So, what part am I going to test? The switch or the senior rows? Where am I taking off?
The switch.
The senior rows.
It would be the senior rows because
So let's go to the senior rows. Okay? Right. So the senior rows being removed. If we was going to do a R1 plus R2, continuity of the CPC, is that the first test?
Yes.
Correct. So, can someone talk me through what do I need to do?
You put the probes in R1.
R1. Before I do that, what do I need to do with the line conductor?
Is it, you take it out.
So I need to take it out, yes?
Yeah, and then you do the same with the CPC and then put it in the Wago, innit?
Okay, so take out the line conductor for the lighting circuit. I need to find the CPC for the lighting circuit, don't I? So now I've got the CPC and the line conductor. What do I need to do with these two?
You put it in the Wago.
I put it in a Wago. So when I put it in the Wago, what am I doing to it?
Like temporarily bonding it?
I'm making a temporary link between the line and the CPC.
Yeah.
Yeah.
Are you following over there? So now I've made the temporary link between the two. What do I need to do?
Test between R1
Use the
and R2 and the lighting.
So test between R1 and
The light. But I don't know what it's
so will it
called.
be R2 and the line?
Yeah.
Okay. So the meter is on. What on? What meter?
It's got to be an
What
ohm.
measurement do I put it on?
Ohms.
Ohms, correct. So when I go to the senior rows, what do I test between them?
R1 and R2. The CP.
R1 and R2, correct. R2 would be the CPC,
Yeah.
R1 would be the
Line.
line. So can you see that?
Yeah.
Yeah? We happy with that?
Yeah.
Yeah? Okay. Can we prove anything else while we're here?
Yeah. Installation.
Polarity.
Polarity.
Okay. Can you see that?
Yeah.
Can you see that?
Yeah.
Yeah.
Yeah? Can someone just flick that middle switch for me? No. Just flick the middle switch for me. No. Switch. That one. Can you see anything in that? Yeah. Okay, thank you. So does that prove polarity?
Yes.
Okay, thank you very much. What does polarity say? Someone at the back? Anyone? What does polarity say? Polarity, what does it say? Anyone?
I think I know, but I'm not sure. Is it that everything is connected properly? Or no?
It shows that it's off or on.
Single pole devices
Okay.
are connected
Electrically sound?
to the line conductors only. If the single pole device wasn't in the switch, nothing would happen when I operate the switch. Therefore, I could not have proven polarity.
Right.
Does that make sense?
Yes.
Okay. So now we've got the resistance, we've done continuity, we've proven polarity at the same time. What other tests can we do on the line circuit?
Installation resistance.
Installation resistance.
500 volts.
Correct.
Yeah.
So what do we need to do when we're doing the installation resistance test?
You need to-
500.
Are you on the board, yeah?
Yeah.
And you can see me clearly
Yes.
from my head?
Yes.
Okay. So, when we do IR, what's the measurement?
500 volts.
Not the voltage, what's the measurement? What are we measuring?
Resistance. So ohms.
So ohms, thank you. So, should the switches be on?
No.
Should the lamp be removed?
Yes.
Yes. Why should they be removed? Are they vulnerable to the test?
Yeah. Yes.
Yes. That's why we remove them. What's the voltage that we use?
500 volts.
So when we use 500 volts, what are we doing to the conductors?
Put them under stress.
Well done. Putting them under electrical stress. So, we're going between line and the CPC, okay? And we're at ohms. So what reading are we expecting when we press this? Less than or greater than?
Less than.
Less than or greater than?
Greater than.
Greater than what?
999
999 what?
ohms.
Before the ohms, what?
M.
What kind of M?
A small M.
Big M.
Oh.
Right. So now, 1 second. Why didn't that? What
You
have
did
we
put on
done?
500.
Thank you very much. 500. So now we should be greater than 999 million megohms.
Yeah.
Okay? That's what we want. Okay? If 500, no problem. 230 will have no problem. Okay? Okay.
What if it isn't also?
If it isn't, then that means, my friend, you're having some short circuit between the conductors, because there is no lamp that's in the senior loads. So therefore, when you have where it says to remove the loads, the lamps, it will read through. Okay? I will demonstrate when we do installation resistance with the socket outlet. So when you do an installation resistance test in a house, you have to make sure everything is being plugged out. For example, the kitchen, the kettle, because it will read through the kettle, and that will affect the reading that you're getting on the meter. Okay?
Could it also damage the appliance that is running?
It could damage the appliance. It could be vulnerable to the test.
Cool.
Yeah? For example, certain dimmers, certain LEDs.
Yeah.
If you do it connected while you're doing an IR, it will actually light up, because you're putting 500 volts through that piece of equipment, and it might be vulnerable. The electronical component, the electrical components within that circuit might be vulnerable to the test. I got it. There you go. Yes? Okay. So now we've tested between line and the CPC. What about the neutral? Do we need to do that?
Yes.
Yeah.
Of course we do. So now we do the same thing. And you can see?
Greater than.
Greater than.
No.
Okay? Yes? Yeah. Okay. So, that will be our lighting circuit. Okay? What other tests? What's the last test for the lighting circuit?
Is it
Go on.
ZS.
ZS. Well
Yeah.
done. Well done. And what does the ZS stand for?
total earth loop fault impedance?
So total
Fault loop.
earth fault loop impedance. Correct. Yes?
Yes.
When we do a ZS, on the lighting circuit, or any circuit, is that a dead test or a live test?
That's a lot.
Correct. That's a live test. We need the supply to do the dead test. Okay?
Hey, sir.
Yes, sir.
You know the ZS, once you find it, is that the same one where when you divide it by the voltage you find the prospective fault current? Or is that something else?
No, it's not. That's the formula for the PFC would be. Anyone remember that? At the back there. What's the formula for the prospective fault current?
ZE equals ZS.
Would that be volts over impedance?
Oh, I think I remember. Is
Would
that
that, I just asked, I just told you. Would that be volts over impedance?
Yes.
Well, to get the prospective fault current.
Yeah.
Okay, can somebody do this for me? 0.3, so 230, so volts is 0.3 in it. So 230 divided by 0.3 ohms. What do you get?
766.
766.
Yeah.
So if we had a circuit that had 0.3 ohms in a ZS, obviously what's the nominal voltage? 230 volts. So if PFC, the prospective fault current, the formula would be volts divided by impedance. So 230 divided by 0.3 gives you 766, and that would be your prospective fault current. For example, if we had a type B breaker, 6 amp, how many fault current would that breaker need to operate it?
30.
30. So therefore, when we do the ZS on the lighting circuit, and say for example we had 0.3, that prospective fault current will be 766. And if it's being protected by a BSEN 60898, which will be a 6 amp, it will tell you 5 times that, isn't it? 5 times 6 is 30, isn't it? So if it only requires 30 amount of fault current to operate that breaker, and the ZS for the lighting circuit is 0.3, the prospective fault current will be 766. So therefore, if you go to Appendix 3 in BS 7671, you will see that the time characteristics that would operate within 1 second.
That's what I said though.
So that will be for that circuit. Okay? When we do ZE, what do we need to do when we do a ZE? When we do a ZE test, what do we need to do?
You gotta turn on the power.
Stand for?
External fault loop impedance.
External earth fault loop impedance.
So you can't check the light or the switch. You have to check somewhere else.
So when we do a ZE, if we look in the fuse board, in the earthing family, remember, they're all the same green and yellow, but however, they've got different names, isn't it?
Yeah.
What's the name of this one?
Extraneous. Supplementary bonding.
Huh? Supplementary. Or would that be a main bonding conductor? What clamp is this? Ooh, BS, say that again? Too many numbers. It's BS 951, which is the earth clamp. So, what cable goes onto if this is your gas pipe, for example, would that be, can someone look in the on-site guide on page 18 or 11 for me, please? What's the name of this conductor? Over there, what's the name of this conductor? All of them are green and yellow.
So
So they
main.
all relate to the earth family. However, they've got different names, isn't it?
Yeah.
Okay.
Supplementary bonding.
Is this the supplementary or is this the main bonding conductor?
No, that's the main bonding conductor.
Can you make sure you double check it? When you look at the book, that's the gas pipe, isn't it? Yeah? What's that conductor? Main bonding conductor. Yes, that's the main bonding conductor. Which one is the supplementary conductor? Under the sink. Okay. What's additional protection? What is considered to be additional protection?
RCDs and breakers.
RCD, well done. However, if I was in a wholesalers selling the RCD, you've just pulled up in your nice little van. Can I get an RCD? I'm going to look. We've got many different ranges. Which one offers additional protection?
BS, RCB, MIC.
What does regulation 415.1.1 says on page 73 of the BS 7671? Additional protection is a 30 milliamp RCD. 30 milliamp. 30 milliamp RCD. If you was in a construction site, it would be a 500 milliamp. If you was designing a building against fire, it would be 300 milliamp. Okay? It's on page 73 in the regs book, on the right hand side at the bottom. Regulation 415.1.1. I can see it right there. Can you see it? It's not there, it's in my head. So, therefore, you remember when we were in the lessons? And I said to you, if you had a circuit in parallel with 3 resistors, each one rating 36 ohms, what would be the overall resistance of that circuit?
0.
Not 12, but, sorry, my bad. I thought you said something. Absolutely right. 12. Why would it be 12 if it's in parallel? What happens when it's in parallel?
The lowest common denominator. The lowest common denominator.
Okay, so if we're doing a ZE, would we need to remove the main earthing coming into the board?
Yes.
Why would we need to remove that?
Z.
Because
It's the main earth.
because it's arranged in a parallel arrangement. To get a true value of the ZE reading, this is why you take out the main earthing conductor. And then you clip onto it. Okay? Neutral on that. Okay? And that would give you a true reading, a bit more accurate. Because this, when you, sorry, man. I don't want you to, sorry, closer. Look that way, behind the camera. When you look at this, can you see on this board, he's put a fly lead to earth the metal box. What name do we give to the metal box?
Exposed conductive part.
Well done, an exposed
String.
conductive part. So therefore we need to put a fly lead in it, okay? So when we're doing this, we're making more parallel parts into the installation. So if we come back over here, we'll remove the earth and you clip onto it. When you're doing your ZE, it reduces the parallel parts. So when things are connected in parallel, you will have an overall resistance will be lower. Does that make sense? Yeah? Can someone give me the formula for ZS?
ZS equals ZE plus R1 plus R2.
Thank you. So how many ways could we accumulate this value, the ZE value? How many ways?
3.
3, correct. Can I get one from the back?
I think the other way around, isn't it?
There's 3 ways we can get it. I do agree. 3 ways. Can you tell me one? How can we get the ZE reading? Give me one method.
Land neutral.
Can you give me the formula for ZS again, please?
ZE plus.
Give me the formula for ZS. What does ZS equals to? ZS equals
ZS equals ZE plus R1 plus R2.
plus R1 plus R2. And I'm asking you, how many ways can we obtain a reading for the ZE? How many ways? For the external loop impedance. How many ways can we get that figure? You said 3. I agree. Can anyone name me the 3 ways? So when you go, why do you think I'm asking you ZS equals ZE plus R1 plus R2? What's that? Does that sound like calculation? That don't sound like calculation. So if I gave you a figure, you just told me ZS equals ZE plus R1 plus R2, which I totally agree, yes?
Divided by 5.
So if I gave you the ZS figure and the R1 plus R2 figure, could you then work out what the ZE would be?
Yeah,
So what is that, Carl? What are you doing? Are you not calculating?
you are.
So if I take this tester and I directly clip into here, and then I go into here, what am I doing? What am I doing to it? How can I see the results in here? What would this call? Am I not measuring it?
You are.
So wouldn't that be measurement?
Yeah.
So that one is measurement by direct testing it.
Yeah.
Yes? The next one, if you've got the formula ZS equals ZE plus R1 plus R2, that's calculation, isn't it?
Yes.
What three letters? Might I pick up my phone and ask, oh, is it possible if I could get I can't hear you.
DNO?
I cannot hear you.
DNO?
The DNO. So, if I'm on my phone and I'm asking someone, the next end on the phone, what is that? What is this? What is that? What am I doing?
Communication?
I am communicating, but what kind of communication is it?
Direct.
Am I making an inquiry?
Yeah.
Am I inquiring about something?
Yeah.
So the ZE value can be found by three ways, can't it? One, calculation. Wake up, wake up, wake up. Calculation. Yes?
Yeah.
Direct measurement. Yes? Hello, DNO, inquiry. Correct? How should we take the ZS on a lighting circuit? Should we take it from the closest point to the board or the furthest point from the board? The furthest. Correct. Because we want a true reading of the ZE. So we're not going to take it one from here to here, is it? The resistance is only from here to here. We want the furthest one from the board. Does that make sense?
Yeah.
Yeah? You got that?
Yeah.
When we tested the bonding, have you heard of the long lead method and the short lead? Does the line and the CPC goes back to the CMOs?
Yes.
They're doing it. Why do you think we link the line with the CPC and then test between those two at the CMOs? That would consider to be the short lead way. Imagine if you had one end of cable, let's say Black Horse train station, yeah? And the next end was up at the college.
Okay.
How could we test that at that end we've linked the line with the CPC?
In check.
All you do is the same thing we did here. At one end, put both of them together in a temporary link. And then go at the next end. Your lead can be short as this, isn't it? You just needed to touch around to the both things, isn't it? That's the short lead method. That's what we do.
Okay.
A long lead method. The cable is at the same distance. One is up at the college, one is down at the train station. A long lead method would be one is at the next end and one's at the next end. Yeah? And we're testing with a long lead.
Why would I do that then?
Why would you want to do that? So I'm telling you, there's two methods.
Oh, okay.
When you're doing bonding, you might need to do a long lead method.
Oh, cool.
If the gas meter was down there and the intake room was over here, you need a long lead method to link. Remember, it's only one bonding conductor, isn't it? Yeah? You see how it works? Yeah? So, what's the first step in safe isolation? Let's say I was at my house and you came to do some work. What would you do first?
Ask permission,
Ask
turn off
permission.
the power.
Thank you. Next step.
Put the lock on.
So,
Make
you've asked
sure.
permission. I've given you permission. So, what do you do after that? Turn off the power.
No.
How would you need to identify the circuit?
Identify the circuit you want.
But before you identify the circuit, what about these?
Oh, you have to.
Are you forgetting these?
You got to use the
Are you
proving.
forgetting this? What's this again?
Proving unit.
What's this?
Voltage indicator.
What does it have to comply with?
GS38.
What does GS38 say about the ends of the tips?
They should.
To be 4 millimeters out, preferably 2.
Well done, well done. What do you think this is?
Finger guards.
Well done. Do you think there's a fuse in there?
Yes.
Well done. Yes?
Yes.
Okay. Once you've done all that, then you've identified your circuit. After you identify your circuit, what do you need to do?
You need safe
Lock
isolation.
it off.
Lock it
And
off.
then lock off is called safe isolation. You
Yeah.
need to prove that this is working again?
Yeah.
On the live source?
Yes.
Yes, you do. To make sure that your equipment is not faulty.
Faulty.
So no one can get a
Injury.
shot. After you put the lock on, what do you need to do?
Put the key in your
In
pocket.
your pocket. Going by the rate that you're going, keeps the end of the day good, isn't it? Good.
Yeah.
Well done. Well done. Then after we've done that, we can
Test.
start to do what we do. What's the name of the first test?
Continuity.
Second one?
Polarity.
Third one?
Installation resistance.
Next one?
ZS.
Next one?
ZE.
What about phase rotation? Do we need to know what way the current is going?
Yeah.
What if we had a three-phase?
You'd have to.
We already know.
If we had a three-phase, L1, L2, L3,
Yeah.
Well, you just.
so we need to know if it's going in the right rotation, doesn't it?
Yeah.
Let's say we had a three-phase and it was connected to a three-phase motor and it's meant to be spinning clockwise,
Yeah.
but it's going anti-clockwise. How could you correct that?
So you just change the.
Rearrange it.
You switch any two of the conductors
Yeah.
around. Okay? So for example, you switch L1 with L3 or something like that. Okay?
Yeah.
And you'll get the right rotation. Yes?
Yes.
Okay. What's the IP rating of the top of the fuse board?
IP4.
Okay. What finger was this?
Index finger.
You know the.
No, BS. British Standard.
British Standard test finger. What's the length? What's
9.
the width?
9. No, I'm saying
Is
9.
it 12 and 80? Have a check. Might be. Are we allowed any dust inside of the fuse board?
No.
What could dust cause?
Fire.
And what could fire cause?
There's no effect.
Before death is going to explode.
Oh yeah.
Okay?
Yeah.
What would this consider to be?
No.
Extremes.
Extraneous. Well done.
I said that.
Extraneous. Well done. Well done. Well done. What would this consider to be?
Exposed conductors.
Exposed conductive part. Well done. Well done, gentlemen. Well done. Shut. Thank you.